Hello, welcome to MathPowerLine. This is problem set 3. We've been talking about how to use trigonometric identities. And there's some groups of identities that we've been using. And basically, the reciprocal identities are used probably the most common. And that's where one trig function can be written as a reciprocal of another. The tangent identities are simply the definition of tangent and cotangent. And the Pythagorean identities, there's 3 groups, all based on the right triangle, where we have the hypotenuse as 1 unit. All right, let's take a look at some examples. I've got 2 for you to try. All right, as you can see here, we are rewriting these and simplifying. So these are 2 separate problems, and you want to use whatever identities or definitions would be appropriate and basically look for the simplest way to write that. All right, pause the video and give it a try. All right, let's look at the first one. Sine theta over cosecant theta plus cosine theta over secant theta. Now, it's generally a good idea to keep sines and cosines the way they are, at least at first, and see if you can use other definitions of other functions. So cosecant theta, I should be able to rewrite that, and secant theta, hopefully you have those memorized. But let's take a look at our list. So cosecant is the reciprocal of the sine function, and secant is the reciprocal of the cosine function. So let's use that in our problem. So we have sine of theta over 1 over sine theta. All right, we'll have to deal with that in just a moment. Added to cosine theta over 1 over cosine theta. Using some algebra steps here, notice that we can multiply top and bottom of this fraction by sine theta. You can also think of it as sine theta over 1 in both places. All right, because this is a fraction here. But what happens is, now the denominator is gone and I have sine theta times sine theta. Now I could multiply by the reciprocal of this fraction too, which is going to be cosine theta, or cosine theta over 1, however you'd like to think of it. So multiply both top and bottom by that same thing, and again the denominator cancels out, and that's why we did that. And so we're going to have cosine theta times cosine theta over there. So now I have sine squared theta plus cosine squared theta, and that should look pretty familiar to us. Yes, there it is. It's one of our Pythagorean identities. Sine squared theta plus cosine squared theta equals 1. And that, again, comes from Pythagorean theorem on a right triangle. So let's substitute a 1 in that place. So that is, in fact, the simplest answer I could get for anything. This whole thing is just another name for 1, and that's definitely simplified. All right, what do we do over here? We have 1 minus cosine theta times 1 plus cosine theta all over sine. Now we're going to use the FOIL method to multiply this out, and you do notice that this is a plus minus pattern, which will give me a difference of 2 perfect squares. So whether you do it kind of the long way using the FOIL method, or you notice and recognize the pattern, you're going to square the 1's and square the cosines and put a subtraction sign in between. All right, that middle term using the FOIL method drops out. So it's 1 minus cosine squared theta on the top and sine theta on the bottom. All right, so either memorizing or recognizing that that is something from a Pythagorean identity. Let's take a look at that. And here it is. 1 minus cosine squared theta is really another name for sine squared theta. That's our Pythagorean identity. All right, that makes it very convenient. So on the top, we're going to have sine squared theta over sine theta. And remember the way that we label this, we put the exponent by the sine word for that function. It's really sine times sine. So when we cancel that out, we're going to have just a single sine factor left over. So this whole thing simplifies to sine theta. All right, well, that gives you a taste here in problem set 3 of ways to simplify and rewrite expressions, even verify identities. Now I have 3 problems for you in the next video that is a self-quiz. So I urge you to give it a shot. Look for self-quiz on using trig identities. Thanks for watching.